Yeah, good evening, everyone. Viewers all over the world, yeah, good evening. Welcome to tonight's class. We'll be looking at principle of mathematical induction. Sometimes it is also known as union. Is that clear? So please, I want you to do me a favor, like, subscribe, and comment. We are all learning together. Is that clear? I'm going to break it down for you to know and understand. Help me share. Thank you and God bless you. Okay, tonight we'll be looking at principle of mathematical induction. Here we have simple question that we'll be looking at. It's not difficult. So how are we going to solve this? That is what we want to look at briefly. Here is the question. Use mathematical induction to show that 1 plus 2 plus 2 raised to the power 2 plus plus 2 raised to the power n equals to 2 raised to the power n plus 1 minus 1, where n is a non-negative integer. So we are going to look at it together. Amen? Amen. Okay. Yeah. Principle of mathematical induction. We have 3 properties that is guiding principle of mathematical induction. One of the properties is 1. Okay. One of the properties, you assume n equals to 1. And if you assume n equals to 1, you are to satisfy or to say that it is true for n equals to 1. This induction, it has to do with 1 to prove the left hand side and the right hand side to be what? Equal. So once they are equal, you are done with the proof. So if you assume n equals to 1, then you conclude by saying it is what? It is true for n equals to 1. Then 2, assume n, amen, equals to k. And this k is just like, bear it in mind, have it in mind that k is just like a constant that you don't need to show the proof. You just conclude by saying it is what? True for n equals to what? K. It is true for n equals to k. Then, the last but not the least is we assume n equals to what? K plus 1. These are the 3 properties that you need to know. Amen. As long as principle of mathematical induction is concerned. Do you understand? So let me explain this last property. This last property is an extension of this second property. So always bear it in mind. Is that clear? It is what? An extension of this second property. Otherwise, you will fail. But I'm going to show you how it works, how you are going to apply the second property. Just like somebody having a bedroom flat and they feel like extending it to 2-bedroom. That is how it is. Is that clear? Do you understand? Do you have any question before we proceed? Please ask. Swasco Gaming. Good evening. How are you and where are you watching from? Yeah. Demi, which country are you watching from? Which country are you watching from? No question? Okay, so let's proceed. It's alright. So, as it is now, let us assume n equals to 1. Is that clear? So, let's consider this property. These are the properties. So, whenever you are solving induction, you have to take note of these properties. Okay, let us assume n equals to 1. So this implies that this your statement, look at the board very well. This your statement means that anywhere you see n, you substitute in 1 here in this series. Amen? Okay, let's write down the series. 1 plus 2 plus 2 raised to the power of 2 plus plus 2 raised to the power of n equals to 2 raised to the power of n plus 1 minus 1. Amen? So now, according to your statement, you said assume n equals to what? 1. So let us test whether the right hand side will be equals to the left hand side by putting anywhere you see n, you just write 1. So if I were you, just forget about this side, just concentrate here. This plus 2 raised to the power n. Amen? So we write it 2 raised to the power of n is equals to what? 2 raised to the power of n plus 1 minus 1, right? Okay, so anywhere we see n is what? 1. So here will be 2 raised to the power 1 equals to 2 raised to the power of 1 plus, okay, 1 plus what? Okay, yeah. Look at it very well. You know, if you are not careful, this, okay, let me just, for the sake of malleance, is that clear? Let me break it down for you, because I'm saying something, although you are not saying what I am saying, both in the spirit and physical, mathematical. Okay, so here, if we do it this way, plus 1 minus 1, do you know that we won't arrive at the left hand side? Look at it. How? Yeah, you may ask, how? Look at it. This is 2 raised to the power 1 is the same thing as 2. Then we have 2 raised to the power of what? 2 minus 1. True or false? Then this is the same thing as 2 raised to the power of 8 raised to the power 2. 2, it means 2 times 2. True or false? So 4 minus 1. As you can see, 2 equals to 4 minus 1 is 3. True or false? It means it is not true for n equals to 1. True or false? It's true. Yeah. But, you know, because we approach it this way. But let us apply indices. Amen? Amen. Let us apply indices here. The indices we are going to apply multiplication law. Go back to your elementary mathematics. That you know, true or false, that 2 raised to the power of n plus 1 is the same thing as 2 raised to the power n dot 2 raised to the power 1. True or false? Amen? Any question? Because I have to break it down for you to understand. In fact, I'll make sure you know this thing more better than the person teaching you. True or false? So if we approach it this way, we approach this idiot this way, you can now see that the left hand side will be equals to 2 equals to 2. Amen? Okay, let's try it. Yeah. So we cannot approach it this way. Is that clear? So what we need to do here, I know very well that in mathematics, induction is one of the difficult topic that students find it difficult, but as long as you are here, I'll break it down for you to know and understand it better. Amen? Okay, yeah. So if you agree with me, it means the left hand side will now be 2 raised to the power n equals to 2 raised to the power n times 2 raised to the power 1 minus 1. You can now see that this is the same thing as this. Amen? Yeah. So now let us substitute it in 1 because we said assume n equals to 1. If we do that, we are going to have 2 raised to the power of 1 equals to 2 raised to the power of 1, then dot 2. Amen? Now minus 1. So this 2 minus 1 is 1, true or false? Yeah. So here will be 2 raised to the power 1 is the same thing as 2, then equals to 2 raised to the power 1 is 2. So 2 minus 1 times 2 is 2. Can you see that? Both the left hand side and the right hand side are what? Equal, true or false? Look at the board very well. Look at it. Can you see? So now we conclude by saying it is what? It is true. This statement is very important. It is true for n equals to what? 1. So it means we are able to satisfy property what? 1. So what is left? We have to satisfy what? Show to satisfy property what? 2. So now we move to property 2. But before I move to property 2, please, if you know you have a question, drop it in the comment section. I will explain it all over again. Is that clear? Let me give you 1 minute to do that. Any question? No question? So we can proceed, right? It's okay. If there's no question, let us proceed further to look at it again and again. Amen? Amen. Okay? So far, so good. That is that. Okay. So let us proceed. Let's proceed. Let's proceed. So can I clean this up? Let me clean this up. Let me clean this up. Yeah. So if you can see what I am saying, both in the spirit and physical, mathematically, I don't think this will be a problem. It's okay. So let us assume n equals to k. Amen. So we now say assume n equals to k. So far so good. So it means we have to write anywhere we see n, we write k in this series. So here we are going to write 1 plus 2 plus 2 raised to the power of 2 plus da 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 plus 2 raised to the power of here we have n. So we put k. Then equals to 2 raised to the power of here we have n plus 1. True or false? It's true, right? So we write instead of n plus 1, since we say assume n equals to k, so k plus 1. Amen. Okay. K plus 1 minus 1. So we conclude by saying it is true for n equals to what? K. You know, I said it earlier that there's no need for you to show it. This second one, assume n equals to k. Just conclude by, after substitution, you conclude by saying what? It is true for n equals to k. So now, I want you to take note of something because I want to do something now You know, I told you that we are going to move to property 3. And property 3, I mentioned it to you that it is an extension of what? Property 2. So take note. It means in the spirit within you, this 2 raised to power k is equal to this. Take note. Is that clear? It means the 2 raised to power k is equals to 2 raised to power k plus 1 minus what? Take note, because I want to do one funny thing here. Look at the board, please. If you have any question, ask. Any question? Dema, where are you watching from? No question? You don't have question? Okay, there's no question. Let us proceed. Let's proceed. Yeah. Okay. So let us proceed. I can clean this, right? Okay. Okay. So whenever you are done with property 2, always bear it in mind that property 3 is an extension of property 2. So now, you know, I told you that just let go of this. Just concentrate on this. This plus equals to. So we now note, I will note that this is equal to this. So now, let us assume, we now assume the last property, n equals to what? K plus 1. So this implies that anywhere we see this, amen? So now, here, we are going to write, listen, we are going to write plus, let's write it, 1 plus 2 plus 2 raised to the power of 2 plus to 2 raised to the power k. This is property 2, true or false? So now the extension plus, you say assume n equals to k. So plus, anywhere you see this, here we are going to have 2 raised to the power of what? K plus 1, which is equals to 2 raised to the power of k plus 1 plus 1. Then plus 1, then minus 1, yes, plus 2 raised to the power of k plus 1. Yeah. We are done. Look at the board again and again. Look at the board again and again. Fatma, where are you watching from? Fatma. I don't understand France. Okay, yeah, as you can see now, you can now see that both the left hand side and the right hand side, they are all equal. How? You know, let's come back here. Note that this 2 raised to the power k is equal to this. So if you can see what I am saying, instead of this, we now let go of this. So we are going to write 2 raised to the power of k plus 1 minus 1. So we replace this with this. Then what we have plus 2 raised to the power of k plus 1 equals to 2 raised to the powers of k plus 1 minus 1 plus 2 raised to the powers of k plus 1. So now what we need to do, you can now see that we are able to prove to have the same thing both on the left hand side and what? The right hand side. So we conclude by saying it is true for n equals to k plus 1. That is it. Any question, please, before we move further to solve another question? Any question? Drop it in the comment section. Do you have any question? These people are writing in French and I don't understand what they are typing. Come on, look here. You see it. Please speak English. Type in English. I don't understand French. Okay, let's proceed further to solve the next question. Is that clear? Okay, the next question says, I can claim this. Wow. Yeah, show that what is the question? Approve. Another example is proved by mathematical induction. That 5 plus 7 plus 9, 5 plus 7 plus 9 plus plus open bracket 2n plus 3, right, is equals to n open bracket n plus 4. It's okay. Let's look at it together. As long as you understand the first example is the same approach. The 3 properties are what needed. Very important. Is okay. So let's go by. Now write 5 plus 7 plus 9 plus plus open bracket 2n plus 3 equals to n open bracket n plus 4. Amen. Okay. So one of the properties says assume n equals to what? 1. The second one, assume n equals to what? K. Then the third one, assume n equals to what? K plus 1. So let us assume n equals to 1. So if we assume n equals to 1, just forget about this side, just consider what is here, 2n plus 3. So 2n plus 3, n open bracket, n plus 4. Let us do it together. It means anywhere you see n, it's going to be what? 1. Here is 2 open bracket 1 plus 3 equals to 1 open bracket 1 plus 4. Amen? 2 times 1, 2 plus 3 equals to 1 plus 4 is 5. Amen? So 2 plus 3, 5 equals to 1 times 5. 5. Can you see now? You can now see that the left hand side is equals to what? The right hand side. So you conclude by saying it is true. Amen. It is true for n equals to what? 1. Any question? Do you have any question? No question? So we can proceed, right? Okay. So let us proceed to, it means we are able to satisfy property what? 1. So let's move to property 2. Is that clear? So property 2 says assume n equals to k. You know, I told you as long as property 2 induction is concerned that you don't need to show, just substitute in the value of k. Then you conclude by what? Saying it is true. True or false? So write the series. We have here 5 plus 7 plus 9 plus da 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 plus open bracket 2k plus 3 then equals to k open bracket k plus 4. So as it is, we conclude by saying it is what? It is true for n equals to what? K. So look at it together. Amen. Any question? Do you have any question? No question? Okay. So far so good. So what we need to do here is for us to assume n equals to what? Assume n, I want you to finish it. Assume n equals to k plus 1. It means 5 7 plus 9 plus da 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 plus open brackets 2k plus 3 then plus, you know, property 3 is extension of property 2, right? So here will now be k open brackets 2 open bracket k plus 1 plus 3 then equals to k plus k plus 4, right? Then plus 2 open bracket k plus 1 plus 3. Yeah. So this is where I'm going to stop. If you have any question, ask. Don't forget to like, share, comment. Is that clear? And in case you have any challenge, chat me up. Is that clear? This is my number. Plus 2 3 4 7 0 3 3 6 6 7 7 3 7. This is my WhatsApp number. You can reach out to me in case you have any challenge. Is that clear? Take note of this number. It will do you good. Thank you and God bless you. See you again. I love you. Bye.